Hi everyone, today I'm going to talk about SAT physics test and how to crack it. And first I'm going to explain the test format. Okay, so the test consists of 75 multiple choice questions, and it's only 60 minutes, so you should be working fast, but that should tell you that those questions are not hard, but they might be tricky. So the second thing to note is no calculator allowed, so it will be fairly straightforward calculations, but you should be able to do simple mental math. And unlike the AP Physics test, there will be no formula sheet, so you will have to remember most of the important formulas, and I will go through some of those during this video. So another unusual thing, there is a penalty for guessing. So if you get wrong answer, you actually will be penalized. And the penalty depends on how many choices are there. So you're gonna get -1/4 if the answer was the question had 5 choices, and -1/3 if the answer was 4 choices, and if the question had 4 choices, and -1/2 point if the question had 3 choices. So that makes sure that on average, if you do pure guessing, you get 0 points. So that means that if you don't know the answer, if you have absolutely no idea about the question, then you probably shouldn't guess. However, if you can eliminate couple totally wrong options, then you should take an educated guess. So I'll go over some strategies and then example of eliminating. Okay, so first strategy is very usual, so very common strategy. You heard it regarding every test. It's answer easiest question first, because it's all multiple choice, so each correct answer is just 1 point. So you should answer those questions first that you know for sure. The second thing you should know is work fast, because as I said, it's 60 minutes for 75 questions. So it means if you do the math, it means you have 48 seconds per question on average. So that means you basically, as soon as you read the question, you need to know what to do already. And as I said, those questions are very typical, so you just should practice doing typical questions, so when you take the actual test, you already know how to solve all those problems. Okay, and the third strategy, as I mentioned before, if you don't know the answer, but you can eliminate few wrong options, then you should take an educated guess. Otherwise, if you have absolutely no idea, you probably should leave it blank, because this way you just get 0 rather than being penalized. Okay, so here I'm going to show how to eliminate. Obviously not right questions here. Obviously not right options, sorry. Okay, so here's the question. The figure on the right shows 2 positively charged particles, and plus q charge is fixed in the position, while plus lowercase q charge is brought close to the big one and released from rest. It says, which of the following graphs best represent acceleration as a function of distance? Okay, so first of all, you should know that acceleration, of course, must decrease, because the further the charge gets apart, the smaller the force acting on the charge, and therefore acceleration should decrease. So that already eliminates C and E. And well, if you think about it, it shouldn't decrease either linearly or quadratically, because the shape on the option B doesn't make a lot of sense, so you should be able to eliminate it. And then, well, it comes to the question whether it's quadratic or linear. And okay, I mean, even if you don't know the formula, eliminating should be enough for you to take a good guess between just A and D. But if you want the answer here, so the Coulomb's force is proportional to 1 over r squared, but it will be the net force, so that tells you that the acceleration is proportional to inverse square of the distance, which is option A. Okay, let's get to the topics covered on SAT. Essentially, it covers AP Physics 1 and 2 plus special relativity, but the questions are much easier than on AP exam. Okay, here are some main topics here: mechanics, electricity and magnetism, waves and optics, heat and thermodynamics, modern physics, and some miscellaneous. So I'll go over each section briefly and go over 1 or 2 sample questions. So mechanics. Mechanics contains a few topics too. It's kinematics, dynamics, circular motion, simple harmonic motion, gravity and Kepler's law, and energy and momentum. Okay, so here's a simple kinematic question, but first let's focus on that gray rectangle where you have relevant equations. So the average speed, you should know it's the displacement over time, average velocity, or it could be the average between final and initial velocity. So this formula here is basically a definition of the acceleration. And this is how to calculate the displacement if you know initial velocity and time and acceleration. And this helps you to figure out final velocity if you don't have time. Okay, so now let's go to the question. Oh, by the way, this equations are only applicable, of course, when you have constant acceleration. Okay, let's go to the question itself now. It says, for an object traveling in a straight line, its velocity as a function of time is given by the following graph here. So which graph best represents acceleration? Okay, so it's velocity time graph, so you should know that the acceleration is a slope of the velocity time graph. So which means first it's constant and positive slope, and then it becomes negative, but it decreases in magnitude. So if you look at the options, this should be the option D, because here it's first constant positive, and then it all of a sudden becomes negative, but slope decreases, as you can see from this graph. So that's why the answer is D. Okay, so next topic is dynamics, relevant equations. Of course, that's not all, but that's something that you should know in your sleep. Net force is equal to mass times acceleration. That's Newton's second law. Definition of force of gravity, definition of force of friction, and this is the Fs denoted by spring force. So that's force, elastic force in compressed or stretched spring. So it's spring constant times the elongation. Negative sign indicates that the direction of the force and displacement are always opposite. Okay, so let's look at the question. And it says, if we know the mass and the net force of the object, what can we calculate directly from Newton's second law? And in order to answer this question, all you should know is this formula, F net equals ma. So if you know net force and mass, it's easy to solve for acceleration. So that's why the answer is the answer is C, acceleration. Okay, this was easy enough. Let's look at another dynamics question. So it says a mover exerting a steady force of 200 newtons pushes the box of mass 50 kilograms across the flat wooden floor. If the velocity of the box doesn't change while he pushes, what is the coefficient of kinetic friction between the box and the floor? So here, first of all, you should of course do the free body diagram, draw all the forces, and there is a force of gravity, normal force, applied force, that is mover pushing it, and the force of friction. So the next thing you should know that it says velocity of the box does not change. So what does that say as? It's means acceleration is 0, and therefore the net force is 0. And looking at this diagram immediately should lead to conclusion that if the net force is 0, we have a pair of those equations. So vertical forces balance each other and horizontal forces balance each other. So now you apply this equation here, but take into account that friction force is actually equal to applied force and gravity force is equal to normal force. So if you do that, you calculate the coefficient of kinetic friction equal to 0.4. Notice that here I used 9.8. For SAT questions you can use 10 for G, but it's not going to change the answer dramatically, so whether you use 9.8 or 10 you should get B. Okay, let's go to next question. It's electricity, energy and momentum, sorry. And here we have a bunch of relevant equations which I'm going to talk about. So first, of course, it's a definition of momentum, mass times velocity. Here it's definition of impulse, meaning change in momentum. It's force times time during which force was applied. So that's the definition of work, definition of kinetic energy, potential energy in gravitational field. This is the work energy theorem. Work is equal to change in kinetic energy. This is our conservation of energy law, and remember this is applicable when you don't have any external forces such as friction, air resistance. And here is the definition of power. It's work per unit time. And here is efficiency. So it's essentially energy output over energy input, but you can express it in terms of power or work, it doesn't matter. Okay, so let's look at the question itself. So here we have that diagram, and it says two blocks are in a frictionless table. Before the collision, the block of mass m, which is this block here, is at rest. And it says if the collision were elastic, what is the total kinetic energy of the blocks just after the collision? So if you read it carefully, it says elastic collision, and elastic collision means our kinetic energy is conserved. And so since this block initially is not moving, the kinetic energy of the system is stored in this kinetic energy of this block. So we just have to calculate the kinetic energy and equate it to final kinetic energy of the system, because as I said, it's conserved. So if you plug in the numbers, you should get 128 joules, which is option D. Okay, next question is circular motion question. So relevant equations, of course, this is the centripetal acceleration, you should know that. And this is the centripetal force. If you notice, this is just centripetal acceleration times mass, which means centripetal force plays the role of a net force in circular motion. And any curvilinear motion is accelerated because you constantly change in the velocity, and that means you should never have zero acceleration when you're talking about circular motion. Okay, so this is the velocity. This is the speed. You can see that this is basically the circumference over a period, so distance over time essentially. And this is the expression of angular speed. It's just 2 pi times over t. Here is the definition of frequency. It's just 1 over a period, and this is the connection between frequency and angular frequency, which is just a factor of 2 pi. And of course, if you compare these two, you should see that linear speed is equal to angular speed times radius. Okay, so let's read the question. A particle travels in a circular path of the radius of 0.2 meters with a constant kinetic energy of 4 joules. Which is what is the net force on this particle? Okay, as I said, centripetal force plays the role of a net force. So it's mv squared over r. we are given the radius, but mass and speed are not known. However, we are given the kinetic energy, and if you recall, kinetic energy is just mv squared over 2, which is 4. So that tells us that mv squared is just 8 joules. So we don't know what m is, we don't know what speed is, but we don't need to know them individually, we need to know the product of those. So now if you plug it in here, you should get 40 newtons, which is option D. Okay, the next question is about simple harmonic motion. So relevant equations are here. This is the period of the mass oscillating on the spring with a constant k. This is the period of the pendulum with length L. So this is the general equation of simple harmonic oscillator. It's displacement from the equilibrium as a function of time is equal to amplitude, which is maximum displacement, times cosine of omega t plus phi. So phi is the phase shift. It's related to where your initial time is. I mean, when your initial time is. So if you start at maximum displacement, the phase shift should be 0. If you start at equilibrium, it should be like pi over 2, because that will turn the whole thing into sine. And this is the total energy of this spring. It's if you recall, the energy of the compressed spring is 1/2 kx squared, and here instead of x I use a, because that will give you the maximum amount of energy, which is total energy of the spring. Okay, so for this question, you should just know this formula here, that t is 1 over frequency, because you're given the frequency and you're asked what is the period of oscillation, so which means we don't even need the amplitude. Just plug it in and calculate it, so the answer is A. So that was way too simple, so we should look at the other simple harmonic motion question. Okay, so we have this diagram and we're told that the block is oscillating between extreme points x and y, which means this is our maximum displacement, and point O is where the spring is natural length. Natural length means there is no force applied. That means this is the equilibrium position here. So the value of the k is known, but the mass is unknown. So we are asked what quantity do we need to know in order to calculate m. So again, if you know the formula, this is pretty simple, because, well, k is known, mass is unknown, so that tells you that, okay, we need to know the period. Okay, so let's scan through the options. The acceleration at point O doesn't give us much. The acceleration of point Y doesn't give us much, because it tells you nothing about the period, about the speed. The speed of as a block passes through equilibrium doesn't give us much. The distance between x and y, well, that gives us an amplitude, but not the period. And the option E here tells us the time required for the block to travel from x to y, and that's what we need. So just keep in mind that this is not the whole period, but half of the period, because period is one complete cycle, and this if it goes only from x to y, this is just half of the cycle. Okay, so let's go to next question. It's gravity and Kepler's law. Not too many equations here. It's the definition of force of gravity between any two masses in the universe. And here is one of the possible expressions corresponding to Kepler's law. It's period squared proportional to radius of the orbit cubed, and it's constant. And here I also wrote circular motion equations, because they're always relevant, since in most problems we'll consider orbits to be circular, so that's why I need circular motion equations. Okay, so let's look at the question here. It's asking us about two satellites orbiting the Earth, and they have circular orbits, and they have constant speed. And we're given the relationship between mass of the satellite 2, and we're asked which satellite has a greater speed. And looking at the diagram, you can see that, okay, satellite number 2 has twice as large radius as satellite number 1. Okay, so in order to solve this problem, you should apply this equation first, and here I just denoted mass of the Earth by capital M and mass of the satellite by lowercase m. And of course, in space, there is no other forces other than gravity. So, and remember, centripetal force plays the role of the net force, so that's why we equate those two. And you can see that mass cancels out and one of the r's cancel out. So we have this relationship, and that is basically enough for us to answer the question, because we can see that the radius is inversely proportional to the square of the speed. So that should tell you that, okay, well, if satellite 1 has radius smaller by a factor of 2, then its speed must be greater by a factor of square root of 2, because again, it's inversely proportional to square of the speed. And that leads us to answer A. Okay. So next big topic is electricity and magnetism, and it splits into subtopics here. So we have electric field, forces and potentials, capacitance and capacitors, DC circuits, and magnetic forces. So as in the previous section, let's look at them separately. So we first look at electric fields, forces, and potentials, and let me pull this somewhere in here. Okay, first let's focus on the equations. This is the Coulomb's law, force between any two charges, and this is the potential energy stored in between any two charges. This is the force on the charge in the uniform electric field E. This is the electric field of the point charge. This is the potential at a certain point created by a point charge, and this is the electric field between two parallel plates with potential difference V and distance d. And this is the expression for potential difference in terms of work and potential energy. So this shouldn't be surprising, because by definition of potential, it's energy per unit charge. So change in potential should be change in energy per unit charge, and by work energy theorem, that should be work. Okay, so let's look at this question. So it says how much work is done by electric field created by stationary charge this to move the charge of 1 nanocoulomb from position X to position Z. Okay, so we're given the charge and we are looking for work. So we just basically need to find the potential difference between point X and point Z. And in order to do this, we apply this formula here. So it turns out that the potential difference is 0, because of course the numerator is exactly the same and denominator appears to be the same, because if you look at the diagram, Rx and Rz are both 3 centimeters. So these two quantities are exactly the same. And that should tell you that the work is also 0. And that is option A. Okay. Next question. Capacitance and capacitors. So this is the definition of the capacitance. It's stored charge per voltage. So this is the capacitance of the parallel plate capacitor with area A and the distance between the plates D. And this is permittivity of free space, and this is the dielectric constant of the dielectric used in the capacitor. And if you have several capacitors in parallel, the resultant capacitance is just the sum of the capacitances, and if it's connected in series, then it's this dependency, inverse, 1 over. Okay, so let's look at the question. It says, which of the following would increase the capacitance of the parallel plate capacitor? Okay, so if you know this formula, this question is very easy. So you just have to scan through the options and see which one fits this formula. So it says using smaller plates. So smaller plates means smaller a, and its a is in numerator, so this is not the right option. So it says replacing the dielectric material with one that has smaller dielectric constant. Again, this is a numerator. If you decrease it, the capacitance is going to decrease. Options C and D are about decreasing and increasing the voltage. So you should know that voltage is not involved here, so that shouldn't change the capacitance, because the capacitance is a property of the capacitor itself. So if you decrease or increase the voltage, it will change the amount of charge stored in the plates, but not the capacitance itself, because again, the capacitance is just a property of the capacitor. And finally, option E says moving the plates closer together. Well, that means decreasing D, and if you decrease in the denominator, C should increase, so that's our option. Okay, let's move on. So DC circuits. So in order to be able to solve DC circuits, you of course need to know Ohm's law, and you need to know rules of parallel and series connection. Also, you need to know what the power is, because all those questions about the brightness of the light bulbs essentially about calculating the power. So let me briefly go over these 6 equations here. It says for elements connected in series, all the current through is the same. This is due to conservation of charge, of course. But the voltage adds up to the total voltage, and the total resistance is just the sum of the resistance of each individual element. For parallel, voltage is the same across every element, because, well, we only can have one potential difference between 2 points. And the parallel current, the total current through the battery, is equal to the sum of the currents in each branch. Again, this is due to conservation of charge. And here we have inverse dependency of between total resistance and resistance of individual elements, and this is derived from this and Ohm's law. Okay, let's look at the sample question now. So we are given the diagram, and it says all 6 resistors are the same, and the battery has voltage V, and it says how does the current through resistor A compare with the current through resistor B. Okay, so you should look at the circuit and figure out that the resistor A is connected in series with the battery, so the total current goes through resistor A, but here in this junction it splits into 3 parts, and since all the resistances are the same here, so we know that it splits into 3 equal parts, and that means the current here should be 3 times greater than the current here, and that is option B. So we can just choose it. So you see, again, if you know this question is pretty simple. So let's look at the other question. So it actually gives us the same circuit, exactly the same circuit, but now it says, okay, the total resistance is 10R over 3. So then the amount of current that passes through resistor A is what in terms of V over R. Okay, so this question is, again, fairly simple if you know Ohm's law. So we know that, as we argued before, the total current that comes through the battery also comes through resistor A, because they're in series. So we just apply Ohm's law, and plugging in the total resistance gives us this, and that's option C. Okay. So the next topic is about magnetic fields and forces. So not too many equations. You basically need to know Ampere's force, that is the force acting on the current carrying wire in a magnetic field, and this is the Lorentz force acting on a single charge moving through magnetic field, and this is the magnetic field created around current carrying wire, straight current carrying wire. Okay, so here we're given the diagram, and the question is asking at which of the points the net magnetic field is 0. So in order to do this, you have to apply right-hand rules that I put here, because most of the times you'll need right-hand rules rather than the equations. So first of all, note that magnetic field can be 0 only if magnetic field due to this wire and due to this wire are opposite at a certain point. That is the only way that can allow us to cancel magnetic fields. And if you apply the right-hand rule here, if you recall, you can twist your fingers. You can grab the conductor and point your thumb in the direction of the current, and then if you twist your fingers around it, that shows you the magnetic field direction. So if you do that, in this situation, that will actually tell you that the magnetic field in point 2 and point 3 are in the same direction. So which means, that directly tells you that the answer is A. But if you're uncertain about which one is this, point 1 or point 4, then you should use this formula here to figure out that the magnetic field strength is inversely proportional to the distance from the wire, and that should tell you that option 4 is not possible, since you have a weaker current here than here. So that tells you that the answer is A. Okay, let's pause it here and continue in the next video.